In this video, we will learn about operations with integers. And by operations, I mean adding, subtracting, multiplying, and dividing. Let's first start by looking at how we add integers together. In order to add integers, the first thing we need to do is check and see if both of the integers have the same signs. If the integers do have the same sign, meaning they're both positive or they're both negative, we're going to add the numbers and keep their signs. All right. If the signs are different, then we're going to subtract the numbers, not thinking about their signs. And after we subtract the numbers, we're going to keep the sign of the larger number when you think about its absolute value. Let's look at a couple of examples. As normal, right, when we see 2 plus 3, well, 2 is a positive number and 3 is a positive number. So what we normally do is we add 2 and 3 and we get 5, right? And so this fits perfectly with this definition up here, that if the signs are the same, then we add the numbers and keep their signs. All right, let's look at another example, part B. I have -5 plus -2. Now, if you look, this -2 is in parentheses. The only reason why I put it in parentheses is to make sure that you see that it's a negative and it's not an extension of that plus sign. All right, but the signs are the same, right? A -5 and a -2. So what I'm going to do is I'm not going to even think about the signs. I'm just going to go ahead and I'm going to add 5 and 2 together. 5 plus 2 equals 7, right? Well, since both of those were negative, when I add them together, I'm going to get a -7. So my solution to that one would be -7. Let's look at part C. In this example, we have 6 plus a -19. Again, that -19 is in parentheses just to make sure that you are aware that that's a -19 and it's not a part of that addition symbol being extended. All right, but this time our numbers are different. And so since they're different, I'm going to subtract 19 and 6, right? We normally subtract the big one from the smaller one, and we get 13. Well, since the larger number, the number that looks larger when we think about its absolute value, is -19, and since that's negative, my answer is going to be a -13. Last but not least, we're going to look at 4 plus a -17. Again, the signs are different, and so I'm going to figure out what 17 minus 4 is. Okay, 17 minus 4 is also 13. And since my bigger number is negative, right, 17 looks bigger than 4 in absolute value, and so my answer is going to be a -13. All right, and so my hope by the time you're very comfortable, I want you to get so comfortable that you can look at 6 plus -19 and immediately say that that's -13. You can look at 4 plus -17 and immediately say that that's -13. All right, but we got to get there. We got to start somewhere and we got to get there. All right, let's look at subtracting integers. All right, subtraction, if you notice when I did these examples up here, when I had this addition, I actually changed it to subtraction in order to help me figure out what this is. The relationship between addition and subtraction is that subtraction is the same thing as adding the opposite. And so when I look at examples for subtracting integers, I'm going to change subtraction to addition and use the rules for addition. Now, when I change subtraction, I just can't change the subtraction. I've actually got to be very careful. All right. For instance, when I have 3 minus 5 here, I'm going to keep my 3. I'm going to change my subtraction to addition. But if I do that, I have to do the opposite of 5. And the opposite of 5 is -5. So I get 3 plus a -5. And actually now, since I have this addition here, my signs are different. I'm going to subtract 5 minus 3 is 2, but I keep the sign of the larger one in absolute value, which is this 5 here. So my answer is going to be a -2. All right. So 3 minus 5 is the same thing as -2. All right. Let's look at another example. 2 minus a -6. In this example, again, we have a subtraction. If we want to change subtraction to addition, right, we've got to add the opposite. The opposite of -6 is a +6. And so my solution is going to be 2 plus 6, which is 8. Let's go to part C here. In part C, we have -4 minus a -8. Again, we're going to want to do some subtraction. Well, if we don't want to think about subtraction, we can do the opposite to add. So I'm going to have a -4 plus, if I change subtraction to addition, I have to do the opposite of this -8, which is a +8. Again, our signs are the same when we have addition here. So I'm going to subtract 8 and 4. I get a 4. And since 8 is the larger in absolute value, my solution is actually going to be 4 as well. All right. And so that is that example. In our next example, we have 13 minus 6 plus a negative 21 minus 15 minus a negative 9. And basically the way I'm going to do this is I'm going to go from left to right. There's a couple of ways you can go about doing this, but that's the way I'm going to do it. All right, so I'm going to start with that 13 minus 6, okay? All right, now that's normal, right? 13 minus 6, that's the same thing as 7. So I get 7 plus negative 21 minus 15 minus a negative 9. Now that I've got that 7, I'm going to do 7 minus negative 21. Remember, the signs are different, right? So I can do 21 minus 7, which is 14. But I take the sign of that negative 21. So that's going to be a negative 14 minus 15 minus a negative 9. All right, now that I have this subtraction here, all right? Remember, subtraction is the same thing as adding the opposite. So the opposite of 15 is negative 15. So that's going to be the same thing as a negative 14 plus a negative 15, right? And now that's like addition. Now we have addition. And so what I'm going to do, since the signs are the same, I'm going to add 14 and 15. That's 29, and I'm going to keep their same signs. So that's a negative 29. All right, and now again, I'm going to change that subtraction to addition. So I'm going to negative 29 plus the opposite of negative 9 is a positive 9. And notice with this addition, the signs are different. So I'm going to do 29 minus 9, which is 20, but I've got to keep the sign of that negative 29. So my solution would be negative 20. All right, that's addition and subtraction of integers. Let's get to multiplication and division. All right. Now, there's a couple of rules that I'm sure you all are aware of when it comes to multiplication and division. So we're not going to spend a lot of time just going over the rules. But when I multiply a positive number times a positive number, my solution or my product is going to be positive. When I multiply a negative times a negative, my solution is also going to be positive. So this tells me if my signs are the same and I multiply, my result or my product is going to be positive. With a positive times a negative, my solution is going to be a negative. And a negative times a positive, my solution is also going to be a negative. All right. So this tells me that if my signs are different, then when I multiply, my product should be negative. Let's look at a couple of examples. 9 times negative 6. Well, one's positive, one's negative. So my solution is going to be negative. And from multiplication tables, we know that 9 times 6 is 54. So I get negative 54. Part B, I have a negative 4 times a negative 13. This time the signs are the same. And so when I multiply, my solution is going to be positive. Now all I have to do is worry about what 13 times 4 is, all right? And just as a review, we'll go ahead and do the multiplication. 3 times 4 is 2. You carry your 1. 4 times 1 is 4. Carry the 1, you get 5. So my solution is a positive 52. Let's look at one more example involving multiplication. I have a negative 4 times 40 times 5 times 2. All right. There's a couple ways you can do this one as well, but I'm just going to go from left to right. All right. From left to right, I'm going to have a 4 times a negative 10, which is a positive 40. Still have my times 5 times my negative 2. All right. 40 times 5 is 200. So I get 200 times a negative 2. And here I have a positive times a negative, so I know my solution is going to be negative, and 2 times 200 is 400. So my solution is a negative 400. That was just one example of how we can solve that problem. Let's go to division. Dividing integers, right? The same rules are going to apply with division, so I'm going to go ahead and write these down real quickly. So we already know that a positive and a positive, negative and a negative, when we do division, we're going to get a positive result. And if the signs are different, positive divided by negative or negative divided by positive, we're going to get a negative result. Let's look at a couple of examples. Part A, we have negative 56 divided by a negative 7. Well, I have a negative divided by a negative, so I know my result is positive, right? And 7 goes into 56 8 times. So I'm going to get as my result a positive 8. Negative 48 divided by 3, right? We have a negative times a positive. Well, a negative times a positive is going to be is going to be a negative. And 3 goes into 48, just as a review for long division, right? 3 goes into 4 one time, we get 3. We get a remainder of 1. We bring down the 18. 3 goes into 18 6 times. 3 times 18 is 18. We get a remainder of 0. All right, and we stop there. And so we get a negative 16 as our solution. Okay. In part C, we have 17 divided by 0. All right, so I want to know how many times does 0 go into 17. All right, this is a red flag. Dividing by 0 is always tricky. We can never divide by 0. It's undefined. All right, but we can always divide into 0. Right, so 0 divided by 17. So 17 is going into 0. All right, and that is considered to be 0. All right, and that concludes our study of operations with integers.